Hi guys, how we doing? Welcome back to another video. This is lesson 11 of me teaching myself microcontrollers using the EBlocks platform, which is developed by a company called Matrix, basically to teach people microcontrollers, and I'm teaching myself microcontrollers using their curriculum. So in the last video, I believe we went through, what was it? It was connection points and PWM. So we made these LEDs flash at different brightnesses. So, well, not flash at different, well, yeah, essentially we're using PWM. So my eyes right now, I can see these as dark and these as light. Obviously, I've got a bunch of light in the room, so you guys can't really see the LEDs, but like that, I mean, so you can see the camera is able to pick up the flashing, but my eyes don't at all. So although you can see it flashing, I can't. But anyway, so next video is now we are going through performing calculations. Apparently, the modern microcontrollers like the PIC are able to do simple mathematical tasks with 8-bit numbers at very high speed. As the calculations get more complex or the numbers rise above an 8-bit value, then the execution time lengthens dramatically. Flowcode allows complex calculations using up to 16-bit numbers and takes care of all the complexities. Is that true? I mean, because the ESP32s obviously use 32-bit. Okay. However, these may slow down execution of the program. All right, all good. So we don't worry about background. Creating user variables is what we're doing. Then we're going to configure a calculation icon to perform arithmetic and logic calculations. Then we're going to create and manipulate variables, perform calculations again, use LEDs with current limiting resistors. Okay, cool. So step number 1, create a flowchart that uses a variable called counter containing an initial value of 1. All right, let's do that. So uses a variable called counter, initialize that 1. Variables called counter with an initial value of 1. I assume you want it as an int, but he didn't say that. All right, displays the value stored in a variable counter on LEDs. Okay, so we probably don't want it as an integer. I don't know, actually. Yeah, well, no, yeah. How are we going to display 32,000 on our LEDs? So we want it as a byte, and we are going to display that. So we're going to set an output on our LEDs, and we're going to send that counter variable there. Cool. Change the simulation speed and build blah 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 to normal. Simulate the program and test that it works. I mean, how do I? Oh, okay. If I'm going to simulate it, I'd need a 2D panel, right? Because nothing. So let's make a 2D panel. 2D panel with some LEDs. We should see now if I simulate this. There we go. All right. So if I change that counter's initial value now, change that counter's initial value to 4, then 1, 2, 4. This one should turn on. Yep. All right. So we're working so far. Modify program by adding a calculation icon to double the value stored in the variable counter. All right. So that we should just tick across. So I'm going to be even more fancier actually. So let's set an initial value of 1, and then we're going to add a calculation. I love hardware. Absolutely love it. I'd love seeing this stuff. We're going to add the calculation. We're going to say counter is equal to counter. Yeah. I mean, no, there's actually a merit to writing like this. Counter is equal to counter times 2. So that will count past these LEDs. And let me speed it up. There we go. We're ticking through. What's going to happen here? It's gone. Why does it go? Let's think about that. So it goes 2, 5, 6, and then I guess because okay, yeah. I was thinking maybe it might illuminate all of them, but yeah, no, that makes sense. Okay, that's fine. So then let's do an if statement. I'm just being a bit extra here. Struck a decision in here, and then we're going to say if the counter is greater than 128, then jump back here, go to connection point, and we're going to declare a connection point here, which is A. So go to A. Yep. All right. So make this bigger. See anything? That should work here. So what we're saying there is that once it gets above 128, then it should jump back to the beginning of the program. Oh wait, no. That's just dumb. My brain's not working. All right, wait. Let's just prove that this ain't gonna work. If it's once is greater than 128, set counter back to 1. Is what I wanted to do. Oh dear. All right, is it gonna jump off? There you go. Boom, it's gone. That's interesting. That why didn't? Anyways, doesn't matter. So we don't need a connection point. We just want to set counter to be equal to 1. So counter is we set counter equal to 1 to begin with. Then we say write the counter value to the output. Then we're multiplying counter by 2. So my if statement just isn't working there. So if counter is greater than 128, is that not how I do greater than? All right. If counter is greater than 100, then I don't know. Like this, that should just. Why is that not working? Did that work? Yeah, that worked. So what was wrong with my 128? Does it? I know why. Because when I multiply, this is an 8-bit value. So when I multiply it 128 by 2, I just get some sort of nonsense value. I guess I don't know what the process is doing, if it has overflow or something. So it's only got 8 bits, so it can only do 128, and then after that, it's just gone. 256 just isn't there, I guess. So that's okay. I can put this whole thing. I can say write counter to the port, and then if counter is less than 128. I'm getting a bit sillily fancy here. If counter is less than 128, multiply it by 2. And if it's not less than 128, nah, it's not going to work either. Just if counter is equal to 128, and I'm going to open my. So if the counter is equal to 128, then set counter to 1. Would that work? So when I multiply it first. Okay, wait. Let's see. Was that smooth? I don't know if that was smooth. So I want it to still turn on 128. Or is it just that there's just a massive, okay. Well, what happens on the real hardware when I'm doing this? So if I don't simulate, I was thinking of adding a delay there, but I guess even on my real hardware now, it's going to loop through this rapid, isn't it? So it's not like these are going to fly at whatever 200 megahertz or whatever it is. Let me turn my lights off so you guys can see. Alright, it's doing it on the A ports. So let's just write that to B, because B is just easier for us to look at. Alright, so switch over to B. So it needs a delay regardless anyway. So let's just put a delay right at the end. We'll do 250 milliseconds. Good enough. So yeah, we still have the problem that, look, the last one is not lighting up. So will that fix this now? Don't know. What's my code saying again? My code's saying that if counter is equal to 128, we should add a delay and then set it to 1. Yep. So that last one's still not turning on, but yeah. So I mean, I've deviated way off the curriculum here, so I'm having fun. This is actually enjoyable. Yeah, man. Yeah, man. All right, where we going? Where we going? Where we going? No! Why? If counter is equal to 128, which it does get equal to there, wait to wait, huh? Yes. I know, because I'm only writing to the output here, up at the top. So what if I write to the output at the end, or if I multiply first, do the calculation first, which kind of ruins my Does that mean, am I now going to miss the first bit? I think I'm going to miss the first bit now because I'm never going to write 1 to the output, because as soon as the program starts, it's going to multiply counter by 2. So that ain't going to work either. So we get the last bit, but not the first bit now. Oh, yeah, bugger. All right, so what do we need to do? We want to write to the output first. We want to write to the output first. So we write to the LEDs first, whatever value we've got, because we've set counter to 1. So we always want to write to the first value first. Then we multiply it. And if it gets equal to 128, we still want to write to that output. Okay, so why don't we do the calculation at the end? So then we write to that output. Because count, yeah. So that cycle when it counter becomes 128, it will write to the output. The LED will turn on, and then it'll get set to 1. But then it'll get multiplied again to 2. So it's never gonna stop. Ah, yeah, bugger. Nope, that ain't gonna go either. Yeah, I don't actually know, to be honest. Alright, I've taken a quick break to go eat, so my head should be working now. If I add a delay after I turn on the output and then do my calculation here. So I set my counter to 1 to begin with, write that to the port, so that turns it on to begin with initially. Then I add a delay, so that will stay on, so I'll see that turn on. Then I double it. Okay. So now it's 2. Once it gets up to 128, then reset the counter to 1. I think I can get rid of these delays. Right, anyways, okay. Reset the counter to 1, goes back to 1. Let's just start all over again. I think this will work. Again, I've detoured completely off the curriculum here. So, should see this turn on first. Yep. Okay. Moment of truth. Will the last one stay on? Okay. So we're kind of back to square one here, that this 128 is not staying on now. So why not? It gets to 128. If it is 128, okay, there's a delay, but then it gets set. Yeah, I'm back at the beginning again, because then it just immediately gets set back to being 1 again. So I guess the cheese way to do this is to just write to that output again here. I mean, that is some trashy code. So if it's 128, write that to the output. That is crap. I'm not really happy with that. I'm not comfortable yet with Flowcode and the flow diagrams. I know how to do this in C, and I would like to find the functionality in the software where I can write in C and then have it converted to Flowcode. So I'm pretty sure I just saw it stay on there. Okay, it kind of jumps a bit. Is that on for 250 milliseconds? That seems like it's on for a while. Have a look. I mean, it kind of looks like it's jumping really quick there. Yeah, I don't know. All right, that's the best I'm going to do. So we're gonna crack on. Let's go back to the curriculum. So add a calculation icon to double the value. Display this value, new value on LEDs. Using an infinite loop to repeat these steps continuously with 300 millisecond delay. So I've gone with 250 milliseconds. What do you see? This is called a running light. Replacing the multiplier with 2. Multiply by 2 with the counter equals counter plus 1. What do you see now? You've just programmed a binary counter. Okay, so what do we do? Flow code. Haven't we done a binary counter already in this? So alright, so now we have a binary counter. So we've done this already, I don't know. Or maybe I just did it and I went off the beaten path again. Alright, so we have a binary counter. And modify the program 1 to display the result of the following calculations on the LEDs of port B. Y. Okay. So 45 plus 52. It wants us to show. Should I just run it in simulation? Yeah. So 45. What was it? 45 plus 52. Counter is equal to 45 plus 52. So 45 plus 52 is that. All right. Is that? Does that? I've done that. 45 and 52. Okay. I writ and. Is that gonna work? Yeah, it does work. Yeah. I don't know what I'm supposed to be seeing here, but okay. 45 or 52 or 52. Okay. And then not 45. Ah, so it's just, yeah, that's cool. So not 45. Simulation failed to compile. Didn't like that. Oh, there. Not, I didn't put a space. Oh, it's not taking the space. So can I do this and not like that? Oh, 45 is equal to not 45. Yeah. I don't know how I'm supposed to write this not. I don't know how, it just says to write not like that, but yeah. And it wants me to do 1 plus 3 times 6 divided by 2 for some reason. 1 plus 3 times 6 divided by 2. I don't know what I'm supposed to be learning here. This seems a bit pointless. var2 is equal to var1 times 3, where var1 stores the number 18 on paper. Check if the results are correct. Alright, I'm not going to do that. Cool. Alright, so that's the end of that one. So basically just showing me how to do calculations. It didn't really teach me because, again, that not 45 didn't actually work. So I'm not sure why. So the counter is just equal to, I do 255 and not 45. Like, to me, that should work. No, so it doesn't like that. So then the Boolean expression there of not, that should work. How can I look at my variables? Yeah, I don't know. Again, there's a lot, as with all educational material, it's not just matrices, but there's just a lot of assumptions. Like, I don't understand how to write not 45. I don't. You literally, all it says there is just to do the not, but does it even give me, okay, it's got numerical. All right, it's got a not there. Yes, it is just a typed not thing. So do I need the brackets? I don't know. I just write not 45. Run simulation. Doesn't like it. Unknown or missing variable, not 45. Yeah, because I keep putting a space and it doesn't have it. So do I put in brackets, not 45 like that? Okay, there we go. All right, I think it's working now. Yeah, so that's how you do a not. You got to put in brackets. Cool. All right, guys, thanks for watching. So that's the end of that one. I'm on page, what am I on now? Page 74. So it's taking a bit of time, actually, this. I've just got all these exercises to go through. The next one's using loops. I'm a bit bored of it all. I feel like there's a lot more I could be learning here that I'm just not. And it's kind of dragging on and going very slowly. And yeah, so anyways, I mean, this is for college kids. So yeah, maybe I'm just not the right target audience. But cool. All right, thanks for watching. And next one, apparently I'm doing loops again. But I've done loops so many times, so I'm not sure what. Create a flowchart that contains an array of, okay, arrays. Nice. Okay, so although it says loops up here, further down here it looks like I'm actually getting to play with some arrays now, so that looks exciting. Cool. All right, see you in the next one. Play with some arrays. Nice.